In this video, I want to take a look at a set of identities that we call the even-odd identities. I want to look at each of the trig functions, and I want to compare the function with x plugged in, or theta plugged in, whatever, some variable plugged in, and the function with negative that variable plugged in. Okay. In a prior math class, you may have learned that a function is even. We call it even if these two things are equal to each other. Classic examples of even functions are x to an even power, x squared, x to the fourth, and so on. Graphically, you're seeing x minus x. Always the case that for x and the opposite of x, if you plug them into the function, the output is the same. Right? These are even functions. Likewise, the function is odd if f of minus x is equal to minus f of x. Right? That is, graphically, you're saying plug an x in, plug a minus x in. Whatever happens over here, the opposite has to happen over there. Right? Something like this, for instance, might do that. Examples of odd functions are x to an odd power. Just f of x equals x. F of x equals x cubed. These are what are called odd functions. The symmetry here is about the y-axis. There's a reflection over the y-axis. The symmetry here is centered around the origin when you look at those graphs. Right? So now, from the point of view of trig functions, what I'm going to do is I'm going to look at an angle in standard position. So here's my angle right here. I'm going to drop a perpendicular here and say, let's say the coordinates of that point are a comma b, okay, which tells me that the side length down here is a and that vertical edge is b. So I want to look at that angle, and I want to look at minus that angle. So if that angle, I'm in standard position, so it's rotated counterclockwise, look at the same rotation clockwise. Right? So look at this here being negative theta in standard position, starting here, right, and rotating down. This is reflection about the x-axis here. However much you turned up, you're turning the same amount down. This point here would be equivalent to a point down there. And I don't care if this is a small angle or if it's a big angle. You know, maybe you're turning all the way out to there. Well, negative would be turning to there. You're still reflected across the x-axis. Okay. Now I don't want those in my picture, so I'm going to get rid of them. I do, however, want to say that this should be in the picture, and that if the coordinates of this point are a, b, then the coordinates of this point have the same x coordinate, but they have the opposite y coordinate. This is down now. Okay. So when I start looking at the trig functions of this in this picture, for instance, I have the sine of theta is b over whatever that radius is. I haven't even figured it out. Let's just call it r. But whatever that distance is, it's the same down here. This is a and this is b. So r is the square root of a squared plus b squared. Likewise down here, it's the same, a squared plus b squared. Right? So the sine of theta is b over r, where the sine of minus theta, so this angle down here, is negative b over r. In this way, I can see that the sine of minus theta is equal to minus the sine of theta. That this output is the opposite of that output. And I didn't write this right. I want the sine of negative theta, so I want the negative in there with the theta, is negative sine of theta. Here, the opposite angle will give you the opposite result. An opposite meaning the negative result. Okay. If I look at cosine, look at cosine of theta, well, that would be a over r. Then look at cosine of minus theta, so the angle down below. So down here the cosine would be this, still a over r. So in this case here, the cosine of minus theta is equal to the cosine of theta. Two very different results. Here the minus sign on the inside produced a minus sign on the outside. Here the minus sign on the inside just goes away. Sine is what's called an odd function because it satisfies that property. Cosine is an even function. When we get to the graphs in a couple of days, maybe another week or so, actually I guess it's a little longer than that, but when we get to the graphs of trig functions, we'll actually see that the graph of the trig function of the sine is similar to x cubed and x to the fifth, where it's symmetric about the origin. The graph of the cosine curve will be similar to x squared and x to the fourth, where it'll be symmetric about the y-axis. Okay. Let's try some other ones here. The tangent. If I look at the tangent of this angle and the tangent of minus the angle, so the tangent of the angle, looking up here, of theta, is b over a. So I'll write that down right here. The tangent of minus theta is down here, is negative b over a, which is almost that one, but with a minus sign out in front. So the tangent of negative theta is equal to minus the tangent of theta. This is like the sine, this is an odd function. Right? The cotangent would just be the reciprocals here, and so the cotangent would be odd just like the tangent is. The secant would have the reciprocals here using r and a, so that will be just like the cosine and be even. And likewise, the cosecant will do the same thing as the sine, because you just have the reciprocals of those two fractions, and the minus sign comes in, and the cosecant will be odd like the sine. Right? These are the even and odd identities. They just come from looking at this triangle and the reflected triangle across the x-axis, an angle of theta, an angle of minus theta. The only change is the y-coordinate changes from positive to negative.